Okay, I want to talk a little bit about what we've done up to now. So we've used the ESP8266 on the Node MCU as a coprocessor, really as a modem, a Wi-Fi interface, and that's originally what the Espressif company was all about, was making wireless connectivity to some other microcontroller, and then it was really the kind of the maker or hacker communities that said, hey, this is a microprocessor and it actually has some interesting features and you could use it by itself. So why have two different processors when you can just use one? And so we're going to talk about the Espressif's line of processors. You have two different units, and we'll be doing some labs with each. And the reason I wanted you to have those, and that's the IoT part of the ARM and the Internet of Things, it's still hard to find a company that can compete with Espressif in their wireless connectivity for the price. The little ESP module that you see here, which underneath this little tin can for RF shielding, is the actually Espressif chip and a flash chip, depending on how big of a flash that you want for your program space. So it's a 10 silica 32-bit chip. It's not an ARM-based chip. And from there, they went to an ESP32, which does the Wi-Fi and things, but puts a second core. Really, there's a third kind of low processing core in there as well. And then also has Bluetooth on the ESP32. But we're going to look a little bit at it. Now, there was a company that made the first version of the Node MCU. So the Node MCU is this whole board. And the Node MCU basically took this that you could get, this little board, and put on, your USB connectivity and easy to program, and pinned out a bunch of the I/O pins. And before that, it was you would buy these and come up with some sort of rig to try and program it, and you have to have resistors in certain combinations and pull certain pins down to do it. And they just went, everybody needs to do that. Let's build a little board. And since then, lots and lots of companies have come out with these Node MCUs. Now, there are different versions, and so there are even some that have different number of pins. So just because you have one, you should check and say, okay, is it the same version that I have? Because being a popular product, it's had lots and lots of different clones. The one we typically get is known as a Node MCU 1.0. That's kind of the one that you see here. And companies like ST and one of ST's boards actually has a spot on their board for one of these little guys. ST has their own product, which is a modem, a Wi-Fi radio in with a Cortex M0 in a little board, a little bigger than that, but they want $30 for it. And a lot of other companies that you see, that's kind of the price range where, this thing you can get for probably under $5. This thing here probably under $2 now in 10 lot quantities out of China. So if you're building a product, $30 versus $2 is quite a difference, and that's why these things have taken off and are in lots and lots of things, and it's just a nice easy way for you to get Wi-Fi. The other thing that we did was over last week's lab and this week's lab, we were dealing with the AT command set and the AT firmware. And even if you bought the $30 ST board, it interfaces with AT commands. Maybe not the same commands, but that same serial interface. Some of them give you I2C kind of interface or SPI interface. So instead of doing the commands over just the UART that we did, you're doing the commands over one of the others. You'll see a few different boards. Sometimes they have different USB modules on there. This is the kind of one that we use, which is the Cypress CP2102. There, we'll go for that one. That's the version 3 board. I can bring it in. Let's visit the page and see if we can get there. Oh, come on, just show me the diagram. Okay. And I don't like that diagram. Let's go for another one. Well, that one, maybe. Nope. Yeah, that's a good one. Let's visit that page. Again, there's lots of different versions and things. So let's see if we can bring that one up. Are you kidding me? Okay. So this has got our Cypress CP2102. Most Windows machines have the drivers and things for it already, but if you don't, you're looking for Cypress CP2102, and it was one of the kind of really first competitors to the FTDI. Like, you're using an FTDI module with Wayne, and the reason FTDI came into existence was way back with Windows 95. They were the first ones that had good drivers for USB. Everybody else failed at it. Microchip had their own version of a USB module for some of their programmers, and they had a little utility that went, if the driver messed up, here's a utility you run that deletes the driver and then lets you reinstall a driver and things, because FTDI got it right, and not many people did. So that's where all of those kind of modules. Cypress had was one of the first companies to come up with something that was very similar in quality to the FTDI modules. So you can see some of these with FTDI, with Cypress. There's a CH431 or something like that. You'd have to, if you look at a USB module and it's not responding, there's a Chinese USB chip that you can find drivers out there for, and will run as well. Now, this is currently what we're looking at, and when you plugged in this to put the AT firmware in, we used the Node MCU and we flashed in this AT firmware. And what the version that you have does is it says, okay, I am going to, the USB is attached to TXD and RXD. And so when I was plugged in there, I could have the same kind of interface that's on the USB by plugging into TXD and RXD. And if I wanted to just do AT command set with something like that, the problem is, because that was the programming interface and also a logging output, the AT firmware puts things on the second serial port. And the second serial port, depending on the one, that's why I was looking around for some, this says TXD0 or RXD 2, TXD2 and RXD2. So it is on D8 and D7. And if some of you look, it might even say, mine says D8 and D7. Some people says D6, D7, D6, RX, TX. But it's the ones right by the TX and RX is that other serial port that you connect to. And in this lab, and when we use it as an AT modem, that's where that AT firmware is going out, that second one. So I've seen a few people in labs just grab it off the board they had and plug it into TX and RX, which you would assume you would do, but that's just this log output for the firmware if you're wanting to monitor what your commands are doing. It's at a different baud rate. It's can be kind of tricky to go and look at the data. Long and short is you're connected to RX2 and TX2 for your commands. And then in the lab, hopefully you'll see data. You either have the plugged in the right way onto your ARM board, onto the RB6 and 7, or you'll have it exactly opposite. And so if you're not getting any commands back, try switching the wires around, and you'll probably find that you're talking and getting it after an AT and OK and things like that. So that was in this mode. So What we want to do after this is say, okay, this was awesome as an AT unit. And, you know, the same firmware, the same AT firmware, it might be a slightly different version. 1.74 was used until very recently. But on the Meadow boards that you have, guess what? It has one of these and it talks, I can't remember if it's SPI or I squared C instead of through the UART to the AT firmware module on your board. And so the Meadow board has a API which goes and lets you do TCP and UDP communications. You'd have to go look up what their API is, but it's talking to the same thing you did using the AT commands abstracted with their API to go and do the connections. Because once again, it's a nice, inexpensive way to get wireless going up on a system. So that's great, but I want to also look at how you can just say, okay, I don't necessarily need another processor. I don't necessarily need an ARM for some things. The ARM processor that you have is capable of doing a whole lot of computation. You have three A to Ds on your 407. You have some DACs. The board has accelerometers. It has all of this, but you may not need that. And so if you looked at the ESP8266, it has one ADC. It's up here, and it's got on the board, the ADC is good from up to 1 volt. Okay, but it has resistor dividers, so the whole board takes 5 volts in. The unit itself is 3 volts, and you can give up to 3 volts on that pin, and there's a divider down to take it to 1 volt, okay, for the A to D that's in it. So that's all done on that board. If you're doing the ESP8266 all by itself, you better only give up to 1 volt on the ADC, okay, and it's powered by 3.3. And so the A to D is also not as accurate as the ARM boards. It's not quite linear through the whole range, and there's all sorts of things you can find on the internet about how to take your data and maybe get more reliable results from something from the A to D. But for reading a sensor, like reading maybe your thermistor or DHT11 temperature humidity sensor, and then pushing the data out to wireless just by itself, that's something that is fairly easy to do, fairly inexpensive, and that's why you find these things in all sorts of things. So I want to kind of look at some of the things that we can do standalone with this. What we're going to do is we're going to go back to your Alex 130 stuff or ESAT 130 and look at the Arduino interface. And so I want to talk a little bit about the Arduino interface kind of thing as well. So if I go Arduino, let's go there. Now, you had Phil for this, right? Okay. So when you go to software, and there is a version 2 coming, but let's it's still kind of in beta, and let's not worry about it for now. But they have here download options. Win 7 and newer, Windows zip file, 8.1 or 10, get it from the store, and then some things if you have Linux ARM. So that's if you want to run it on, for instance, the Raspberry Pi or something like that, or you have an ARM laptop or Mac versions. I like you to always download the zip file. And so if you download the zip file, it's not system-wide install. And I don't want it to be necessarily system-wide on the installs. And so you download the zip file. Excuse me. Good thing I have coffee. So you download the zip files. Go there. Now I stick a bunch of this stuff in, excuse me, DevTools. And you'll see I have a whole bunch of versions of the Arduino. I have the 1.816. That's the one that I just downloaded. And you unzip it, and then you stick it in someplace. And so I have to go there to go and launch it. I have to launch the Arduino thing separately. Um, and then so I unzip it and I rename it to whatever. In this case, I'm going to play with ESP stuff. ST, the stuff I talked to you about the ESP8266. There's a whole STM32 Duino interface. So you can use a lot of the things that you used, like digital write and stuff in LX130 with your ST board. Only instead of running at a 16 megahertz processor, you're running at 168 megahertz. Instead of having a 10-bit A to D, you have three 12-bit A to Ds. Some of the things that are there, sometimes your pin numbers, you go, okay, I want to talk to a different port or whatever. What's the pin? You might have to go looking in the header files to see what they actually called, how they actually map the pins. D0 to D7 work. Just like you would expect, whether it's an ESP32, ESP8266, an ST, D0 to D7. But when I go look on the 407 board, it doesn't say D0 anywhere, but one of them is, okay, but you might have to go look, like I said, in some of the headers or documentation to go and find it. So I have all these different ones for an Uno, for an ST, for ESP8266, all of these different ones. So I just unzipped it and stuck it there. But before I do anything with it, what I want to do is I want to put a portable directory. Before you open it up at all, you make a portable directory, lowercase portable. If you do that, when you open it up, it says, oh, you want stuff local to that directory. If you don't do that, it says you want stuff in the system wide, and it puts it in your hidden app data folder under your login and sticks a lot of your things there. For instance, you download libraries and things, it will go stick them over there. So if I'm working on stuff, and sometimes you will find, for instance, a TFT library that I finally got that works with my screen. That's awesome. And I go and do all sorts of things. And then I have my code, and at home I go and take it, and I have my source INO file, and then I go and make a new project, and then I try and find what library I had, and none of the libraries, because sometimes there's a few, none of the libraries are working. Now, hopefully your documentation at the top tells you what's going on, but if not, then you know you don't have it there. It's in wherever you last logged on under the hidden app data folder, and it's over in there. If you put portable, it sticks it in there. Okay, and so any of the libraries that I needed, any of the development tools, because by default, the UNO comes with the AVR 8-bit microprocessor development tools, but it doesn't have the 32-bit ESP8266 ST stuff, any of those tool chains. So I've got one here, and it's going to put all of the development tool chains for that product in there, okay? So just by going portable. Under Visual Studio Code, if you've looked at Visual Studio Code, same deal, but with data. Okay, it's not called portable, it's called lowercase data. Okay, and so we have that there, and then if I go and open up, so I made portable, I open up, and then things I do, it should go and stick them in this portable directory. So I just opened this up. Let me just get rid of that one for a moment here. And so I don't have the anything set up for, it's currently seeing it's the Arduino Uno. I don't have anything else kind of set up for it. And so if you go to search for ESP8266 Arduino core with Wi-Fi chip, GitHub, this kind of looks like it might be it. Let's see, Arduino core with the Wi-Fi chip. Latest release, Arduino and ESP, okay. And there's different versions. What you want is Boards Manager. Okay, and if you go to Boards Manager, and if you're doing that for your 407 board and you want to program that, go STM32 Arduino and it will come up with a similar link, and it'll come up with a similar board manager. And again, I would unzip another one and call it ST in your dev tools. I've got an ST version that has my ST stuff. I like to keep them all separate. Some of the examples are generic and work across everything, and some of the examples are tailored to just the certain boards. And so I like to have everything all separate, so I know all the things in my ST folder are the examples I have all running with ST and so on. So let me just go back in there. And so here it says install with Boards Manager, and it says, hey, enter HTTPS, this whole thing here, this JSON. It's a JSON information on what the boards are. And so if I go to my Arduino interface, I will go File and Preferences, and it opens up this. And so some of the things that we have here are, do you want to display line numbers? Do you want to be verbose during compiling or during uploading? If you're having problems and you're not quite getting the hints on what's going wrong, verbose gives you the individual compile errors. And so like we saw in the debug in our ST boards, so it'll tell you more information. You may or may not want that, but you have these kind of options. But here's the additional boards manager, and you can put multiple ones down, each one on separated by a comma to bring all sorts of different boards in. And they're getting a little better at handling that. It used to be one big massive set of everything together. They've put some tabs in it. But here's the board. And so I just go OK. And then if I go under Tools, Board, I want to go to Boards Manager. And it says downloading here. So let's scroll all the way down. There is the ESP8266. Same thing if ESP32, you go ESP32, Arduino, and it will show you that kind of information as well. And so there is online help. It will take you back over to the page that we were just at when we did our search, and you go install. So because I did install here and I did portable, it's sticking it all in wherever I put that directory under that portable directory. So it's having all of that information kept there. And the reason they say portable is because you could take your whole Arduino directory with, and it even has a folder for all your sketches and things by default in there. You could take that, grab it, put it on a USB stick, and then it is portable, and you can go and take it home and put a copy over onto another computer. If you just did everything from a USB stick, the one problem with that is you can lose your USB stick. So, and the AVR by default is installed. So we have that. So now when I go Tools and I go Board, it has this subcategory. Now this never used to have this. The previous versions, they would just fire all the boards. You'd see all the Uno boards, all the ESP boards, all the ST boards. At least they put it in a tab now for this. And so here, when we do anything, we are going to be looking at the Node MCU 1.0. So that's the one there. It's based on the ESP12E module. And so that's the one you would pick that would know most closely to what your board is. But there's all sorts of different boards. WeMOS is a board that tries to be just about as big as this little unit here. So if you, but have the USB interface and things on it. But there's a bunch of different boards you can buy with different setups. And so I want to be that one. So let's go and click that one. And then if we go Tools, and we'll go now, we look at the board. There's all sorts of different options here that weren't there with the Uno. And it says, hey, it thinks that your built-in LED is on pin 2. We'd have to go look. I can't remember what pin it is on the Arduino. It's usually pin 13. You're uploading, that's great. Your 80 megahertz, your flash size for the 1.0 it knew. But if you had different options, you can go and change that. And then there's all sorts of different things that you can come and do on here. There should be port. When we go over to port, I don't have it plugged in currently, but it should show you that it is the um, uh, on the COM 7, something other than my COM 3 and COM 11 right now. Oftentimes it will say it is ESP or something like that on the board. So you have to always select which COM port it is on. Yeah, that's all I want to. Most of the thing we can leave other than selecting that. Okay, when I go over to File and go look at examples, one of the things that it has done is it has a bunch of examples down here specifically to the Node MCU. And so there's a ton of different examples that you can go and check. It also, it says specific to the Node MCU. You can also run the standard examples, which are, for instance, what we always do, our hello world, our basic blink. So you can put your blink and see that it is all working. And so you can use it just like you were using your Arduino Uno, but it is now, this guy. So like I say, depending on where your uh, button is and things like that. So, but if we go and compile, then if I go back to my Arduino ESP8266, we go into portable, instead of it being empty, it has all sorts of different information in it now. And so if I have the different packages for ESP8266, we have lots of menus and submenus. Down here in ESP8266 hardware, boards.txt gives you some input on it. Variants, here you would have to go looking for, what did we say it was? The Node MCU. And there's pins arduino.h. And so let's open with WordPad. So this is telling me D0 is on pin 16, D1 is on pin 5, D2 is on pin 4. So that's going to tell you where it is. Now here we've got those marked, and it says D0, D0 through D8, except sometimes D8 says there's two D6s on some of the silk screens and things. But that's where you're going to find it. On the ST boards, same thing, except it's got your 407 has tons of different ports and pins. Well, it goes, instead of D whatever, it's just got the pins, and it will say, port A0 to A15, port B0 to B15, and it will tell you what kind of number it associates it with. And so you can say maybe 48, and it's like C5, port C bit 5 on your ST, something like that. This is where you would go find that kind of information. Okay, under variants, and of course under ST or node or what have you. So that's where you get some of those. So first thing, for instance, I would do, you see it's gotten really complicated down below here. Program memory, over-the-air programming, disabled. I don't have, it says it's 115.2, it's on COM7 is what it says. And for instance, if I do an example and I do just a blink, so this should be running the blink and compiling it with the other compiler. And so we could just go verify. Should have put verbose on. To blink the light. Okay, so now it says we have whole bunch of a ROM. There's 231K in our ROM. It says here 260K altogether, 24% of program storage, with some of that to go and blink our light. This is saying blink LED built in. So if they've defined that right in the headers, hopefully our light would blink when we go and run that. And so at this point in the game, I haven't gone and tried to see if I need to remap it. And of course, my network won't work when I do this. At this point in the game, you just plug in. It says it's on COM7. We'd have to go and see if it is on COM7, and you just do upload, and hopefully it'll go and upload. Yeah. No. Yeah, that's a good point. On some things, some programming systems it wants you to hold the flash button or boot buttons or whatever they say in the different ones to put it into the right mode. On the Node MCU, the fact that you're going over and programming it, it toggles things using the little USB module to put it in the right mode to go and program that. There's other environments where it completely ignores you until the pins are in the right place, but they have made it so that that will trigger it as part of its reset going over to this. So no, you don't have to do that. In uh, the ST boards, for instance, the ST407 that you have, we have an ST link that we use, or on the you can program it without using ST-Link if that was gone or disabled or what have you, or you just had the chip in by itself. You could program it using the onboard bootloaders, which are in ROM in the ST boards. And I think you did that with Wayne. Device firmware upgrade, DFU mode, with Wayne's ARM board, because they don't have an ST-Link there. In fact, there's no pinouts. The pinouts that you would normally go to talk to the unit through an ST-Link are not pinned out on the board. And so you can't talk to it generally with an ST-Link, but you can use the built-in bootloader off the USB, and that is how you did DFU mode. So for instance, I've programmed the Meadow board in DFU mode just using the CubeMX IDE. So saying which wipes out all of the .NET stuff and just use it as an ARM board. So you can do that kind of thing. Anyway, so yeah, you don't need to hold down the boot button. If you go and do the flash mode like we did with the putting in the AT firmware, that doesn't know to do that in the right order like the programmer does here. So you have to hold down the boot button to put it into the right mode. Okay, and so I just want to go File, we'll go Preferences, and we will go, I'm going to go, well, I'll do them both there, and let's just hit it again. When you want to see what kind of stuff it's actually doing, it's actually compiling a whole bunch of stuff. And this is if it says it can't find something, and you go, oh, it's got an error in something, it doesn't like something in one of the libraries I've gone and installed. What doesn't it like? I have no idea. Looking at verbose, you'll see an error here, and it kind of tells you. It says, for instance, this is C users meld DU, dev tools, Arduino, ESP, portable packages, ESP tools, Python, really kind of buried all the way. But you can trace that to find what file it wants. Some libraries give you some generic options, and then it goes, well, if you want something else, you have to change the header file. The header files are here for all those libraries. Just like we put header files in, they're just kind of buried, right? So you don't see it on the main interface. But if you need to change things, change a configuration, then you may need to go in to those header files. Where are they? Well, they're going to be in your portable directory, and you can trace wherever it says the error is, or trace where some of these different directories are. And so, for instance, if I'm going into here, our sketchbook as well, there are my If I put in some libraries, you're going to find it there, like the TFT library. That's where I'm going to find a lot of these kind of things. And for instance, if I want some different libraries, if we go include library and go manage libraries, if it ever comes up. Okay, so it knows also about your ESP8266, but there are some libraries specifically to UNO, some libraries specifically to certain things. So let's say I wanted a pub sub, which is getting something out onto the internet and um, pushing data there. So if I looked at PubSub, it says, hey, connect a board to cloud using MQTT, ESP MQTT, IoT platform, MFU. There's all sorts of ones. And that's kind of where I like, if you selected one of these, any one of these actually would get data out using what's known as MQTT. And we'll talk about that kind of next day. If you pick one of these, their APIs aren't cross-compatible. You have to pick one and run that library, and hopefully it works for you. And sometimes they don't. In some of the OLED displays, I found one library works great, another library doesn't, or because of the way they implemented the library, all of a sudden your temperature sensor doesn't read. So you either have to go into libraries and figure out what the conflict is by searching what we just looked at, or you pick another library that hopefully doesn't conflict. And again, the source code for those is all there, so you can go digging as much as you need to do. But if you picked a library, then you probably want to keep it and use that library next time instead of trying to say, okay, my code did run, but where was the data? So for instance, look at all these different libraries that say stuff about pub and sub. And so you would go and look and read the different things about them and decide to pick one. For instance, more info takes you hopefully to a GitHub page, something like that. Another thing to look at is the versions. This is under one, and so I kind of wonder. This is one here might be great. It's by this Dreed 47. You can go to the page. It's 1.01, still in beta, so you can go and look at what other people have done and submitted to the community to go and use as resources. Chances are, if you want to use, have you used the little laser rangefinder with Wayne yet? You have a little laser rangefinder? Okay, so those are awesome. Those are little ST parts. And it's just like your ultrasonics in 130 that you did, except it uses laser and it looks at wavelengths in the picometers in order to calculate distance and things. It's fairly accurate over its range. There's a bunch of different ones that have different range specs, but really good for using fluid levels in tanks, all sorts of things. You can do your whole hand thing. There is some sample applications in this interface to be able to go and use that is able to detect whether you're moving a hand across something, whether you're moving it, whether you're doing this to simulate a button push. All of that stuff can be run with an ESP, with an ST, with an Arduino, using the libraries that are in here. Somebody has submitted all of that kind of stuff for you. So that's kind of all available. You can go and look at the web pages or the GitHub links for all of these different ones. And like I say, there's usually a lot of different submissions. So it's finding out which one is going to work for you and then getting to know that API for doing that. Some of these things you can't just go and click. Some you have to go and read. For instance, this one here says a library that provides a Wi-Fi MQTT connection to an ESP8266 ESP32. If I have an ST, it's probably not set up for me. So I probably would need to look at a different library for that. It might not even compile. You'll find if you pick a library specifically meant for an UNO, specifically meant for an ESP, you have an ST board and it goes, yeah, I can't find a lot of things in the files that were brought in. Okay, so there you have to look at kind of some of those. Everything we do here is in the Arduino interface. We can also use, the Arduino doesn't have a great debugging interface. The AVR series of chips wasn't particularly awesome with that. Your ST boards, your ESP boards have better debugging features, but the whole Arduino interface, other than printfs, isn't really set up for it. And I think in their 2.0 and even they're trying to fix some of that. Visual Studio Code, you can run something called Platform IO that needs to have this installed first. For instance, will give you debugging features similar to what you've seen with what we've done with the Eclipse-based ST stuff. We'll leave it there. Next day, we're going to continue on looking at what we're actually going to do standalone. First thing you should do is try and see if you can make something go and compile when you're going to use this. And then we're going to start programming, do a couple of labs with this one, then do a couple of labs with ESP32. Thank you.